Hello and welcome to another wonderful day of math. So to start off, let's do a warm-up looking at central and inscribed angles. So go ahead and pause, work these out, and then press play once you're ready. Okay, so for this first one, it is a central angle because the angle is in the center. And for these, we know that the outside is the same. So this one is 110 degrees. Okay, this one's a little trickier. This one's inscribed, so we're looking for this angle right here. And we know that this is going to be 1/2 of this length right here. But we don't know that one yet. However, I know that this is 102 and this is 110, and all three of these need to add to 360. So I'm going to do 360 minus 102 minus 110. And that gives me 148 for this outside one. And once again, I need to divide this number by 2 to get the inside. So when I divide by 2, that gives me 74 degrees. Okay, let's move on. Okay, so we've worked with central and inscribed angles. So now we are going to talk about angles that are outside of the circle. And these are called circumscribed angles. Circum means around, so if you think of circumnavigating the globe, that means sailing around the globe or the earth. And scribed, once again, we talked about, means written. We're still on GVC 4. I can use properties of circles to solve problems. And today's two learning targets are finding the angle measure of a circumscribed angle given an arc measure, and working backwards, finding an arc measure given the circumscribed angle. Who uses this crap anyways? So a couple years ago, I don't know if you guys remember, there was a solar eclipse in August, and I lived far enough north that it was only like an 1.5-hour drive for me to get to a place where I could see the eclipse in what they call Totality. And that looked like this picture over here, and it was absolutely fantastic. You started to hear different insects chirping because they thought it was nighttime, and it looks like there was a sunset on the horizon no matter which way you looked. And this right here was just spectacularly glowing, and it's one of the coolest things I've ever seen. So if you guys ever have a chance to be in the path of totality for a solar eclipse, take it. It is worth it. Most other places in the world, so down here, the eclipse looked a little more like this. It didn't really affect the light in the area. There was still a lot of light around. It didn't look dark. And it kind of looked like someone was eating a really delicious cookie. So still kind of cool. And, you know, a lot of people watch the shadows for this one. But not nearly as cool as a total eclipse. Both are cool. This one, trust me, is like 1 billion times cooler. So in order to figure out what the path of totality is, scientists have to use these types of angles. And let me show you what that would look like. So let me get out my circles. So here is the sun. Here is the moon. We're going to move the moon a little down. Here's the moon. And then we're going to have Earth. Except the sun is a lot bigger than the Earth, but just bear with me for this one. Okay? So to find totality, we need to know which line just barely touches here and here. And we're going to move Earth down a little bit so it fits with my diagram. Boop. And also covers here and here. And once again, I am terrible at drawing diagrams. Okay. So Earth is right here. Okay, once again, this is not to scale or anything like it. But to figure out where has the totality, you need to be right in this little angle on the Earth. And scientists know the actual measurements, so can figure that out. And today we are going to learn the math that will help you figure out where to know where a total eclipse is. Okay, so for this first one, you're going to watch me. And real quick, let's talk about rectangles. I know that's exactly what you wanted to talk about while we're learning about circles. So this is a rectangle. I know because it's got 4 sides and 4 angles. So with a rectangle, I know this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. So when I add these up, I get a total of 360 degrees. Okay, now another fun fact is, let's see if I've got a, ooh, here we go. Whoop. Okay, here I've got a parallelogram. And we could do the time to do it, but remember how we talked about like our parallel lines with transversals and whatnot. So I know that these 2 angles are equal. And these 2 angles are equal. And I also know that the sum of these angles is 360. Now if we really wanted to, we could do a proof that shows that any quadrilateral, that means shape with 4 sides, even if the angles are different, whoop, it's still going to be 360. Okay, so just trust me. Any quadrilateral is going to be 360 degrees. Now, Mrs. West, why are you making us learn this? Well, that is a great question. Thank you for asking. I'm going to show you how this applies to circles. So here, I know that this arc measure right here, whoop, is 130 degrees. I want to find this circumscribed angle. And once again, it just barely touches the circle twice. So the first thing I want to do is turn this into a quadrilateral. So I'm going to mark the center. Boop. So I know a couple things now. So since this is a central angle, I know that this angle right here is also 130 degrees because the arc and the central angle are the same. So I know this is 30 degrees. If an angle only touches the circle once on the outside and it doesn't go through like that, here it just touches once, I know that this is 90 degrees and I know that this one is 90 degrees. Okay, so that means that 90 plus 90 plus 130 plus whatever number this is going to give me 360. So 90 plus 90 is 180. So I'm, for the sake of this, just going to ignore these 2 angles. So I know that 180, because that's what's left after I subtract the 2 90s, minus 130 gives me this angle measure right here, which is 50 degrees. Okay, now Mrs. West, that was so much and I got really confused and I didn't understand any of it. That is okay. I was just explaining why the math checks out. From here on out, we're just going to do the easier part of the math. Okay, so here, I've got this angle here, and I'm wanting to know this one. So the shortcut, 180 minus 65 equals, and this is a 0. Sorry, my mouse handwriting isn't very good. But 180 minus 65, and this gives me 115 degrees, which is this length right here. Whoop. Okay, let's do some together. Let's do some together. Okay, go ahead and copy this one right here in your notebooks or on a piece of paper or wherever you want. Just don't draw on your walls. I don't think your parents will be too happy with you if you start coloring on the walls, even if it is for math class. Okay. Once you have it drawn, go ahead and press play. Okie dokie. So I know that this right here is 127 degrees. And I know that this angle and this angle need to add to 180. So to undo addition, I'm going to subtract. So I'm going to do 180 minus 127. Go ahead and do that in your calculators. So 180 minus 127. And this gives me 53 degrees. And that would be correct. Okay, let's try another. Go ahead and do this one right here. Whoop. So draw and go ahead and try this one on your own. See what you get. Okay, so I start with 180. I'm going to subtract 130. And I get 50 degrees. Isn't that what I got 53 up here. I'm like, that's really close, but that makes sense. Okay, let's do this one. So once again, what number do I start out with? Good, I start with 180. What number do I subtract? Perfect, I subtract 64. And this gives me 180 minus 64, 116. Whoop. Okay. Do this one on your own, and then press play once you have your answer. Okay, you should get 115 degrees. Hopefully this is making sense to you. Now we're going to make it a little more fun. Okay, so for this one, I'm given the circumscribed angle, and you don't have to write anything down. I just want you to listen for this one. But it wants me to find this big ol' outside one. Okay, so in order to do that, first I need to find this angle right here. And I know how to do that. It's 180 minus 57. So go ahead and do that. 180 minus 57. And this gives us 123. So I know that 123 is this green part right here, but I want to find the blue part. Now remember, how many degrees are in an entire circle? That's right, 360. So I'm going to do 360 minus this 123. Do that in my calculator. And this gives me 237. And that is my answer. Okay, let's try some of these. So go ahead and copy this one in your notebook. This top one right here. Whoop. And then once you're ready, go ahead and press play. Okay, so it is asking me to find this big part right here, and it gives me the 72. So first, I find this, which I know is 180 minus 72, which gives me 108. So that's my first step. Now I need to do 360 minus my answer, which is 108. And this gives me 252. Okay. Go ahead and do this one next and set it, do the first part by yourself. Oh, just kidding, don't do the first part by yourself. We're going to do this one together because it's a little different. So here, it gives me this one. And it wants me to find down here. So to do that first, I need to find this part. So I'm going to do this backwards. I'm going to do 360 minus 241, which gives me 119. Okay, so that's this guy right here. Now in order to find this one, I need to do 180 minus the answer, and that gives me 61 degrees, which goes right here. Okay, here, go ahead and set up the first part. So I want you to find this right here. So to do that, I'm going to do 360 minus 245. That gives me 115. And then now I do 180 minus 115. And that gives me 65 degrees. Go ahead and try this one on your own. Once you're ready, press play. Okay, and you should get 226. So today's assignment, once again, it is on Canvas. You have unlimited attempts, so please repeat the assignment until you are happy with your score. You got this, guys. You're doing great. Keep up the great work, and I will see you next time.